Welcome to my code. This is a code for project 2 of Engineering 1331. Well, my group's code. This is the upper triangular form / backsub code. This will take a matrix, perform data validation, such as size, where the size must be n by n plus 1. If the size is wrong, then of course it would ask the user to redo their input. Right here, it would call the output from the uptry function. From here, it would create a new matrix, which is a duplicate of the input, create a multiply variable, a count, and it will get the size. It will then run through the code, column by row, and first perform a check if the current value is equal to 0. This whole check right here is so that it prevents the code from dividing by 0 and giving NaN, which is a not available value, because you would have divided by 0 if that happened. Else, if everything works, it would multiply the current row by the multiplier, which is predetermined by the formula used to calculate this. It would replace the whole row by the multiplier times the count, which is part of the data validation up here. Basically, count would jump back up a row if the previous row is 0 until it finishes running through the whole code. This, of course, it makes sure that it doesn't divide by 0. My code would then flip the matrix, and then grab the size of the flipped, and then this is the whole flip thing, and it would run the flipped matrix inside backsub right here, which again grabs the size, makes a vector where it's the size of it's a 1 by the amount of rows, and this subs basically will store the coefficients of x1, x2, x3, etc. Right here, it would run through the code, take the last row and the last column, separated from the answer row and column, which is the initial last row, but it would grab basically the second to last row, and it would go from the first row of the flipped matrix, which would be a 0, 0, x, and then the answer. It would isolate x, set that value to constant, this const right here, which updates every loop. It divides the whole, and multiplies the whole end row of square, it's not square, but SQ, which is basically it takes a square out of the first n by n rows, n by n of the initial matrix, flip matrix. And then that would happen, and after each iteration it would get rid of the last column of square, so each time the size of square would reduce until it's just 1, and then after that it would subs I of the loop would be assigned a value const, which is the coefficient, and this is the code in action. This case, and there you go. That's the code, and those are the coefficients. Of course, this is triangular form, 3 zeros, and it would ask if you would like to go again, in which case let's put no. This is part 2 of the project, numerical analysis. This part will check a series of inputs, a vector basically, convert it into an f of x function, and then run it through bisect root, which uses the bisect method to find the x-intercept. First, it would ask you for basic information such as the coefficients, the maximum error, and the bounds. Then it would ask you, again if you inputted it wrong, and repeat until you get it right. Once you get that right, it will check if the function does have an x-intercept. Okay. The bisect method uses endpoints to slowly narrow down where the intercept is. The bisect method takes two variables and finds the average. The number is plugged back into the equation if the f of x, the function 15, like say function of 15 is -3, then 15 will replace the right bound, which was a different number. And then it finds the average again, and it always repeats that over and over until the endpoints are very close. Say x equals 13 and the other endpoint is 13.001. The difference between these two values would be 0.001, and that would be the error that the user inputted. When it is less than the user's inputted error, then the code stops. So it'll keep on running until the code until that error is less than your input. Our first plot is iterations on the x-axis, and our y-axis is the error of iteration, basically the difference between the endpoints. Our second plot is the iterations on axis, and our y-axis is the difference between the codes and the actual root. And yeah, all this is the code, basically. And thanks for watching.